Hello Ace, this is RetroTK2 and today we're going to look at abstract classes in C#. If this is your first C# video, I'd strongly suggest watching the series from the start. Card should be on your screen now. And if you haven't already, might I suggest downloading the channel files that accompany this video. Card should be on the screen once again. So let's get started. What is an abstract class? Well, according to the Microsoft Docs, the abstract modifier indicates that the thing being modified has a missing or incomplete implementation. The abstract modifier can be used with classes, methods, properties, indexers, and events. Use the abstract modifier in a class declaration to indicate that a class is intended only to be a base class of other classes. Members marked as abstract or included in an abstract class must be implemented by classes that derive from the abstract class. Abstract classes have the following features. An abstract class cannot be instantiated. An abstract class may contain abstract methods and accessors. It is not possible to modify an abstract class with the sealed modifier because the two modifiers have opposite meanings. The sealed modifier prevents a class from being inherited, and the abstract modifier requires a class to be inherited. A non-abstract class derived from an abstract class must include actual implementations of all inherited abstract members and accessors. Use the abstract modifier in a method or property declaration to indicate that the method or property does not contain implementation. Abstract methods have the following features. An abstract method is implicitly a virtual method. Abstract method declarations are only permitted in abstract classes. And because an abstract method declaration provides no actual implementation, there is no method body. The method declaration simply ends with a semicolon, and there are no curly braces following the signature. The implementation is provided by a method override, which is a method of a non-abstract class. It is an error to use the static or virtual modifiers in an abstract method declaration. Abstract properties behave like abstract methods, except for the differences in declaration and invocation syntax. It is an error to use the abstract modifier on a static property. An abstract inherited property can be overridden in a derived class by including a property declaration that uses the override modifier. An abstract class must provide implementation for all interface members, and an abstract class that implements an interface might map the interface methods onto abstract methods. We'll go over interfaces in the next C# video, Ace, so don't worry too much about that for now. Right, as usual, a ton of really good information there, Ace, and we're going to go straight into it now. Open up Unity and create a basic C# script. As always, make sure you give the script a different name than any other class in your project. I want to use the classes that we used in the last video, Ace, in polymorphism. So I definitely say you should check out that video first before proceeding with this one. The card to it should be on your screen now. And because of that there as well, Ace, that means I'm going to need to put this, well, I'd say wrap this tutorial 24 all in its own namespace. And if you'd like to know about namespaces, you can check out the C# video on it by following the card on your screen now. Okay, so namespace, we'll just call this polymorphism. Polymorphism. Wrap that up in there. Probably could actually call it tutorial 24. Actually, I'll do that instead because I think that would be a little bit better. So we'll have 24 and then the class 24. Brilliant, Ace. And then we're going to wrap this one up as well in tutorial 25. Of course, I want to keep these both separate. Probably on your normal code base, you would just use the one class and have it, extracted out into maybe its own namespace. Or maybe if you were going to do something like this and copy a piece of code, I would usually advise against that, Ace, but hey, here we are. Okay, so let's get stuck in. Okay, so last time we created a base class called shape, and then we derived pretty much everything we could from it using the derived classes, square, rectangle, circle, and of course the other triangle shapes, and some L class as well. I'll tell you what, we'll get rid of that L class. And yeah, so this is all, as you can see, these are implementing different things using polymorphism, and it's very unlikely that we'll ever want to create a shape class. So having something like this, shape equals new rectangle, as you can see, this is perfect. This is exactly what you would want. You would always want to instantiate some sort of rectangle object, we'll say, or object rectangle as a shape variable, but you would never ever want something like this. It's very unlikely you would ever actually want to instantiate shape as a shape class, because, well, I mean, really, what's the point to it? I mean, I suppose you could put in, maybe you could have a constructor that would allow you to take a rectangle, and then you could probably pass in some parameters as well to signify length. But whenever you wanted to take advantage of polymorphism, usually it's better to just make a derived class from the base class, override the behavior that we have. Remember, if you remember, we did the log parameter and log area, and the area in the perimeter was also overrode as well. So you never really want to instantiate this shape class, and this is where abstract classes become a real, I want to say, nice feature of nice language feature of C#. So here, as you can see, now I've added the abstract modifier to this. You'll see that we cannot create an instance of the abstract class. As the doc said, you cannot create this abstract. Yeah, well, as you know. Okay, so that's brilliant. That's cool. So now we want to go in and, you know, maybe just add in our rectangle class again, so that we can do that. Okay, sweet, brilliant. So, but we can take this one step further, Ace. So we've got this get method, Ace, and all it does is return 0 float for the actual area. Now, we don't really want that. What we want to do is force our shapes to actually implement the area. So I'm going to create a new class, and I'm going to use one of our triangles. So I'm going to have, we had equilateral triangle down here, and I want to create a right angled triangle. So let's bring this one up here and call it right angled triangle for the shape, and we're just going to leave it at that, I think, for the moment. Here. So as you can see, there's no real, I'm not really being forced to implement anything to a right angle triangle. So I can instantiate right angle triangle right here, and if I was going to log out its actual area, I mean, I can't even input any parameters for this or anything like that. Ace, it's just pretty much as is. Now, admittedly, you can't really force the programmer to implement a constructor for this, so I suppose for that we do actually have to input our own one. So I'm going to do, I believe, 3, 4, and 5 is the correct lengths for a valid right angle triangle. I think that's actually called the Pythagorean triplet, maybe. I can't remember this, to be honest. Okay, so 3 would be, I guess, length, breadth, and then the hypotenuse, I guess. Hypotenuse, as you know me, is. The spelling is brilliantly terrible. Typo in hypotenuse. There it is, okay. Hypotenuse. Nope, come on. Don't fail me now. Let's get it going. Okay, cool. And then the breadth. Yeah, brilliant. Fantastic is missing out an A there. I do hate the actual fact that I can't, yeah, it sort of does come up and sometimes doesn't, but hey, not bad. Okay, cool. So as you know, then we can sort of go and use ReSharper to help us out here and fill in a lot of the implementation for us. Now, I mean, but as you can see, that we haven't been forced to input an area and we haven't been forced to put in a parameter. Well, what we can do here is actually make these abstract and make the get aspect of it abstract as well. So now we don't actually have to input any sort of implementation for our get. We pretty much just leave it as is. And now you can see that we actually get an error up here saying abstract inherited member area is not implemented, which of course it isn't. So now if we right click, or no, sorry, Alt and Enter on here with our cursor and go implement missing members, you'll see now it inputs an override for our area get method on our actual property. So now we're forced to return the area, and the actual area of a right angle triangle is, I believe it's length plus breadth, no, length multiplied by breadth divided by 2, I believe. Let's double check. So as you can see, it's length multiplied by breadth divided by 2, as we all sort of knew. So let's do the length multiplied by breadth, or breadth, okay, divided by 2, and that's all divided by 2, of course. Very, very good. But as you can see, is now we're actually being forced to implement possible loss of fraction, of course, because it's not an F. Brilliant. And I also want to just rename this to breadth. Is that right? Surely that's not correct. Or is it? Maybe it is breadth. Breadth. Who knows it? Who knows? Who cares? So as we can see, that's all well and good. Okay, cool. So yeah, as you can see now, we're forcing it. We're making it so that we don't care about this area. We don't want it to return just any old value. We don't want it to be 0 whenever we return the area. We want it to be actually forced to be implemented with this. And I suppose if you didn't have this, so if we just started from nothing, you'd know, oh, okay, we actually need an area for our right angled triangle. That probably means we're going to need to implement a way for us to get the area of the right angled triangle. So what do we need? Oh, length and breadth. Length and breadth, add that to our actual constructor. I suppose you wouldn't necessarily need the hypotenuse, and I suppose you could work out the hypotenuse as well from the actual length and breadth, using your a squared plus b squared, which would equal c squared, and the c squared would be the hypotenuse squared, but don't worry too much about that is for the moment. Anyway, so we can do the exact same thing as well with our perimeter. I kept saying parameter whenever I meant to say perimeter in the last video, Ace. I'm deeply sorry about that, but hey, who cares? So as you can see, add the abstract for the parameter, exact same thing, use it for the get, and then now we can go up, Alt and Enter, implement the missing members, and now we get a chance to go in and, well, use this to work out our perimeter. And the perimeter of a right angle triangle is the length plus the breadth plus the hypotenuse. So there we go. All very good and in working order. Let's just double check this to make sure that the perimeter of the right angled triangle is all of that. It of course is all of that. So as you can see, this square root of a squared plus b squared is the actual hypotenuse. That is how they work it out. I suppose I could put this in as an actual method, but I'm not even that bothered by it, to be honest, because let's face it, we're actually trying to figure out about abstract classes and their actual use. So yeah, as you can see, it's now, so even though now we've added abstract to the area and the perimeter, you'll see that on the other classes, because they are overriding the area and the perimeter, this isn't an issue, except in the triangle class, where of course we are getting issues with this. So I suppose you could possibly make triangle class abstract as well. So now that it inherits from that, it should all hopefully work. So it's, because it's abstract, so now shape is abstract and now triangle is abstract, because chances are you want a specific triangle. You don't want to just have just a triangle on its own. You want it to be the right angled, scaling, or isosceles, equilateral, and all that fun stuff. And you can have these now inherit from triangle, as you can see. Completely fine, easy peasy. So if I got rid of the area, you'd see that we'd get complaints about the area, and we still wouldn't get any sort of complaints with the triangle class as well, since it in itself is abstract, which is all brilliant. So with all that said, well, now as you can see, so here we get an actual issue with the area. So as you can see, now remember, if you remember in the actual polymorphism episode, we added in a new version of this instead. So you can't use the new modifier on abstract classes or abstract methods. You have to use the override in order for it to override the area, since the actual, technically this counts as a virtual method, if you want to call it that. It doesn't technically, but you understand what I mean, yes, in terms of the syntax. So you can't use new, you have to override it and do it that way instead for it to keep up the contract. So yeah, I mean, whenever I'm thinking about other things that we could do, yes, I suppose we could try and do static, although we haven't actually went over static, the keyword static yet, or have we? I don't think we have. I'm pretty sure we haven't gone over it yet, because I wanted to get all of the polymorphism stuff and actual class specific stuff out of the way in terms of instantiations and stuff. Don't worry too much about it, is. But so you actually see that you can't use this on a method, because you'll get a big massive override method cannot be static, since why would you want it to be static? surely it needs to inherit from the actual thing itself. So since it actually, well, whatever, we'll get into that. So this is sort of shows you how to actually create an abstract method is using the get method. It will, well, yeah, I mean, as you can see, it will just simple as this. You don't actually have to have a method body. We are not going in through here and declaring our method body. But this is the important thing here is, so as you can see, we have an abstract method, that's fair enough, but we can also add in implementation as well to our method if we want. We don't have to make this abstract, so we don't have to do abstract here because it's not abstract. It's a fully fleshed out method, but we can make this virtual if we want to, so that we do have some sort of like default behavior that would be like a log value, but then we could override that actual method log perimeter in our, well, now everything's complaining because it doesn't have its get method is, so we do actually need to get rid of that. But we could actually override the log perimeter method. So we could implement it similarly like it would with the abstract methods, abstract get methods for the perimeter and the area, you know, on our properties. Or we could just override just a standard virtual method, log perimeter, in our normal class. But we can also just leave it as is and have the implementation that is, well, implemented in our actual abstract class. So hopefully you can see the actual power of all of this is, because really we never ever want shape to be instantiated. It would be kind of a coding error if we did do that, but not having it like that, making it so that we actually do have to have it, a lot of this stuff implemented, such as an area and a parameter, makes it really, really good. It's good for anybody who's trying to implement our actual shape abstract class will know, oh, we need an area and a perimeter to be implemented. We can't just rely on the actual implementation in the abstract class. So yes, hopefully you can see the use of abstract methods, and I think we're going to leave it there. So that's it. Rate, comment, and subscribe. Yes, I hope you're enjoying this C# series. I'm having a good load of fun with it. I want to try and get it nice and quickly wrapped up so that we can move on to hopefully a Unity project. You can email me at retrotk2@gmail.com with any sort of problems that you're having with this series. Thank you for watching this, and I'll see you in the next video.